Okay, this lesson's on 8D, on multiplying, dividing rational expressions. Again, it goes back to fractions with polynomials. We're going to start off by showing how do we simplify these polynomials so we can work with them using division and multiplication. Let's start with just numbers, no variables whatsoever. And a lot of us say, how do we reduce 12 over 48? Well, a lot of us say we can take a 12 out of the top and take a 12 out, and we're going to be left with 1 over 4. Okay. What I'm going to do is kind of show you a different way. That way, when we get to variables, we know how to handle those situations as well. When I see this, I'm going to take a 12 out as a factor and leave it as 1, and take a 12 out of 48 and write it as 4. So notice the top is 12 and the bottom is 48. Notice also I use everything in parentheses because you can always cancel parentheses. So when I see this, whatever's in the top and the bottom cancel each other out, and that's what's left over. And now, so you don't need parentheses anymore, so you just write it as 1/4. So what we're going to do here is we're going to show the same thing. We're going to see that 2 is a factor, x is a factor, and x is a factor. I'm going to use parentheses to separate factors. And we can see that those two factors cancel each other out. When I look at the next one, what can I take out of the top? I can write this as 2 times x plus 1. On the bottom, we have x just as a simple factor. Notice no set of parentheses can cancel each other out. So we can't reduce anything. A lot of times, people want to see the x's there and cancel those out. You can't do that because it doesn't work for both of them. Okay? So I'm actually going to undo that one there. And moving on to the next one. Okay, now here, notice if I take an x out of the top, I'm left with 2 plus 1, okay, which can be reduced to 3 over x. Okay, and this is a very good problem to show us because look at the x's cancel each other out, and I'm left with 2 plus 3, which is the same thing as 3 here. Sorry, 2 plus 1 is equal to 3. Okay, a lot of people want to say, can I just combine those right away and get 3x divided by x and cancel? Yes, you can. Okay, look at it again at the top, and what's the GCF? Take a 2 out, and we're left with x plus 2 on top, and on the bottom we have a 2. Those two are factors as well. You can always separate factors in parentheses because it's multiplication. Take them out, and you're left with x plus 2 as your final result. Okay, so that's what we have for this one here. So I'm just showing that you can break everything down into parentheses. That's the key, even with the numbers or simple polynomials. So let's take a look at these examples here. Again, I'm going to break up the top here. So we take out an x, and we have x plus 7. And on the bottom, when I see x squared, that's really x times x. So when I look at this problem, one set of x's drops out, and we're left with x plus 7 on top divided by x. Nothing else to reduce because there's no other GCF. On the top, I'm going to factor that. That's going to be x minus 5 times x plus 3. And on the bottom, we have x minus 3, x plus 3. Notice the set of parentheses. So you're looking for what set of parentheses are the same. X plus 3, x plus 3. Therefore, your final result is x minus 5 divided by x minus 3. Okay, so that's what we're shooting for here. Notice in the end result, you don't need parentheses anymore because it's now reduced. Let's take a look at the next page. On the top here, what can I take out? I can take out a 2. Okay? And again, I don't have to put the 2 in parentheses, but I like to because it shows it as a factor. And we have x plus 1 here. On the bottom, we're going to have x plus 3 as one factor, x plus 1 as the other factor. And once again, notice parentheses cancel each other out. So that factor and that factor are the same. They cancel each other out, and you're left with 2 divided by x plus 3. On the next one, notice we have a quadratic on the bottom, so I'll do the bottom first. And we have x plus 4 times x minus 4, and on the top we have x plus 4. What we're going to do next is we're going to cancel the x plus 4 from top to bottom, and we have this on the bottom. So what goes on top, you still need to show something, so you put 1 over x minus 4, okay? And that's our final answer. So you do need a placeholder right here, and I'm just going to put a little note here to remind us of that, because a lot of times people want to say, well, it's gone, what do you put there? You need to put something there. All right, so here we have, again, 2 more problems. On these 2 here, I'm going to have you try these problems here, okay? So let's have you try these problems, the thing. Again, this one, I believe, that one might be the exact same problems. Let's take a look here. And it is. So don't worry about doing this one. Okay? But let's go ahead and try this one here. So I want to have you guys try that one with reducing. Now I'm going to show you another example here. Notice the big multiplication problem. Whenever you're really multiplying, you're multiplying this times this. Okay? And this times this. So really, that dot's meaningless. What I'm going to do is break everything down into factors. The top here, I'm going to do 3x, and we have 1 minus x left over. Again, throw everything in parentheses. I'll do a different color for this side over here. So we're going to have simply x plus 5, then x minus 4. Okay? On the bottom here, we're going to do x plus 5, and then simply x minus 1. And for the next one, we'll do in black. We simply just have 3x. So 3 and x. And really, I'm separating those because those are different factors. So I'm looking for what can be canceled. Well, the 3x and the 3x can be canceled. And what else can be? X plus 5 can be canceled with x plus 5. But notice here what I'm looking at. We're looking at this 1 minus x and x minus 1. They're very simple, but what's different? The sign. So what I'm going to do is I'm going to rewrite 1 minus x, take a negative 1 out, and show it as negative 1 plus x. And that's really what this is down here. This is negative 1 plus x. And notice those two things are the same. So if I cancel those two out, we're just left with a negative 1 on top, x minus 4 on top, and that's gone. So really we just have negative 1 times x minus 4, multiply out the negative 1, and we have negative x plus 4, and that's all she wrote for that one. Okay? Again, always look at back your problem. Make sure that everything is canceled out. So again, this was one element, that was one element there. Okay? Let's take a look at one more example. Okay, and again, when I see this one, I'm going to put it over 1 and make it to a fraction and put everything in parentheses. So I'm going to rewrite the problem. X squared plus 3x plus 9. Looking for factors 9 to go to that. Can't really happen. So we're just going to leave that there. We can't factor it. But watch what happens here on the bottom. Remember here we have x cubed. So we break that down to your a minus b pattern. A squared minus 2ab plus 2ab plus b squared. Again, for first semester. So we're going to do x minus 3, and then we're going to do x squared plus 3x, and then plus 9. And notice here we have two large sets of quadratics that cancel each other out. Those two are identical, and then you're left with x plus 2 divided by x minus 3. Okay? So there's your final result. So everything can be factored, not just with simple binomial times binomial, but looking for that pattern. Okay? The last example here I'm going to show you is what do we do with the division problem. Well, what you want to do is flip the numerator and denominator in the back half of the problem. So we're going to have 7 times x, and then 2x minus 10. And again, nothing could be simplified there. So I'm going to show that in parentheses. That's a factor, and then times, and then walls. I'm going to do the bottom part first. So that's going to be x minus 5, x minus 6, and then I'm going to do the numerator now in the denominator. So that's going to be simply x, and then x minus 6. What can be canceled? Let's take a look. X's are now gone. The x minus 6 is now gone. The 2x minus 10, actually I can break that down. So let me rewrite that. And again, look for those things too. Look to see what's left over. So I'm going to take out a 2 here, and we're left with x minus 5. And then we say, all right, what can be simplified here? X minus 5 is now gone, and what's left over? We have a 7 left over, a 2 left over, and that's really about it. So this all reduces down to 7 divided by 2. Okay? So that's our end result there. What we're looking for there is on division problems, flip the back half of the problem. Multiply by the reciprocal. All right, and this last problem here I want you to try for our next lesson, and we'll go from there.